Carnegie Mellon has a very long history, a very successful one, of building integrated circuits and creating all of the technology that's needed to make integrated circuits more powerful, more efficient. And these are the tiny chips that you find in all of your favorite electronic gadgets and appliances that are in everything within our lives. People refer to Moore's law as what has defined the scaling of transistors to smaller and smaller dimensions, which is really what has caused the cost of electronics to go down and the power and performance of them to go up. When you think about where computers are in our lives, whether they're in our cell phone, they're in our credit cards, they're now in medical devices that are traversing through our body, it's really amazing what has been accomplished. And that's all because we could make these integrated circuits smaller and require less power. We've done some work on design methods with companies like IBM and Intel, which with some government funding has led to results that we did commercialize, and we even commercialized ourselves with a startup company called Fabrics. Fabrics worked with semiconductor companies and also was ultimately acquired by a California company. We're now in an era of looking at what is called neuromorphic chips, which are those inspired by the way the brain actually operates. When we think of Internet of Things and sensors everywhere in the world, cameras everywhere in the world, we're collecting all this information. We actually have to store it and process it somewhere. And you can't send all that data to the cloud would collapse. Instead, you really want your chips that are placed in different locations to be able to work with that data in real time and make sense out of that data and turn it into information. And that's a big focus of what we're doing in the future with integrated circuit research.